Okay, so in this lesson, we're going to start talking about the slope of a line. And so this part is where we're going to find the slope of a line given 2 points, on that line. So just remember in a previous course, you probably remember the slope of a line as being the slant. Sometimes students will refer to it as a slant or steepness of a line. All right, so it's how steep a line is. So for example, the question that you have to find is, what's the slope of this line? So how steep is this line? It's kind of like a roof. How steep is your roof? And then, so notice that when we look at lines, we always go from left to right. So as we go from left to right, your y values, look at the y values. The y values on this line are getting bigger and bigger. So the y values are increasing. So we say that this line is increasing. So you're going to hear us refer to the phrase increasing or rising, falling, constant, vertical. Okay? So this line here is rising. So this line is rising. My y values are increasing, so this line is rising. Over here, as I go from left to right, my y values are decreasing. So notice the y values are decreasing, they're getting smaller. So we say that this line is falling. Okay, it's falling. So as you go from left to right, you always read a graph from left to right, just like you read a book from left to right. So your y values are decreasing, so we say this line is falling. Okay, so here the line is rising, here the line is falling. Okay, all right, now let's go back and talk about the idea of a slope. So now we know what the idea of a slope is. So the idea of a slope is the steepness of the line. How steep is this line? Maybe I should also say this. So when we talk about steepness, so I'm going to go ahead and draw this line here. Let me do it on the same coordinate plane. So let's look at this. So I'm going to draw this line here. I'm going to draw a line that is going to rise. So let's say I have this line here. I'm just making up this line. I'm not worried about whether the line goes through any of the where the grids intersect. Grid lines. I'm just going to draw this line. So we look at this steepness here, and then I look at this line here. Okay, and so I'm going to call this line line 1, L1, line 1. I'm going to call this line L2. So notice that, you see, in terms of a roof, if you were to walk on a roof, which roof do you think would be less dangerous to walk on? Line 1 or line 2? All right, well, hopefully you said line 1 would be less dangerous. If you had to walk on a roof, line 1 would be the steepness that you would want to walk on, because line 2 is more steep, or I should say steeper, more steeper. So line 2 is steeper than line 1. So that means, now remember these lines are rising, so let's just talk about, we're keeping the fact that the line is rising, not falling. So that means that the slope of line 1 is smaller than the slope of line 2. So the slope of line 1 is less than the slope of line 2. Line 2 is steeper. Line 2 is steeper. So when we talk about the slope, you're going to see that this slope here is going to be larger than this slope. Okay, so line 2 is steeper than line 1. So line 2 is steeper than line 1. So that's going to mean that the slope of line 2 is going to be bigger than the slope of line 1, or the slope of line 1 is going to be smaller than the slope of line 2. Okay? All right. So now let's talk about some definitions of slope. How can we define slope? All right. So slope And all these formulas, these definitions are going to be important, so you really need to know those, especially for college algebra. All right, so the slope is defined to be this. All right, so it's going to be a ratio. It's going to be a ratio of the change in y. So it's a ratio. So it's a you're going to have a numerator and the denominator. In the numerator, it's very important to keep in mind that we have the change in y. Y is in the numerator. And in the denominator, we have the change in x. Change in x. So it's a change in y divided by the change in x. Again, it's important that you keep in mind that it's the y value, there's the y values that will be in the numerator and the x values that will be in the denominator. So it's change in y over change in x. Now, another way we can say that is this. It's the remember when you look at the y-axis, the y-axis is the vertical axis. So this is vertical. The y-axis is vertical. The x-axis is horizontal. Again, the y-axis is vertical. The x-axis is horizontal. So another way we can say this right here, the change in y, is we can say it's the vertical change, vertical, because remember the y-axis is vertical, the vertical change, and I want you to notice this, vertical change over, and then the x-axis, remember, is horizontal, or the horizontal change. Horizontal change. All right. Now notice that the y-axis goes up and down, right? So it goes up and down. So if I start here at this point and I go up, I'm rising. If I start here at this point and I go up, I'm rising. And then the x-axis horizontal. So if I start here and go horizontal, I'm kind of like, I'm going to use the word running. So I'm running here, walking, running, rising. So think of a lot like going up a hill. So you're walking and then you're rising. All right, so another set of words that you're going to hear about slope is rise over run. Rise over run. Okay, so the slope is change in y over change in x. Sometimes we refer to it as a vertical change over the horizontal change. Sometimes we refer to it as a rise over run. Okay? All right, now here's how you're going to use this idea of the definition of slope. Okay? So let's go back to the lines that we drew earlier. So let's go back to this line right here. All right, so we have this line. I have this line here, and this line has an infinite number of points. Remember, these points are solutions to whatever that equation was. So there was an equation that developed this line. All right. And so remember, you graphed equations earlier, so now we're looking at the slope. So these points are the solutions to that equation that you dealt with. Now, it's not important to know what the equation is here. All we want to do here is talk about, well, what is the slope of this line? All right, so we're going to use this definition that we just talked about, change in y over change in x, vertical change over horizontal change, rise over run. Okay, now to talk about the idea of slope, to find the slope of this line using that definition, I've got to pick 2 points on this line. It does not matter which 2 points I pick. Okay, it does not matter which 2 points you pick. So, for example, always pick points on a line that intersect on one of those grid lines, because those are integers. It's easy to deal with integers. Okay, don't use something like this point here. All right, see this point? Because you would have to estimate what those coordinates are. So use something like this, because it goes through a grid line. So you know that this point here, this right here, right here. So that point has coordinates 4, 5. All right. So always choose points on the line. If you're going to use this definition to find the slope, always points on the line that are integers and not decimals or estimates, because you're trying to find the exact slope of this line usually, most of the time. But over here, I'm going to go ahead and use, let's say, this point right here. All right, that point. All right, and so that point right here has coordinates, let's say -3, so that's -3 comma -2. Okay, so here's how you're going to use the definition that we just talked about. Now, in a few minutes, we're going to use the actual formula for finding the slope of a line given 2 points, and that's the one that most students will use, is the formula. All right, so the formula is easy to use. You just need to be able to plug numbers into the formula, and you come up with a value. Okay, so let's talk about finding the slope of this line using the definition that we just wrote. Okay, so you got to start at one of your points. It does not matter which point you start with, but you got to pick 2 points of this line. Again, it does not matter which 2 points you pick. It does not matter. I chose those 2 points. So, and I'm going to start at, I usually start at the point that's located below, that's at the lowest point. That's lower than the other one. I'm going to start here. And again, it doesn't matter. We'll come back and we'll maybe look at this one. It does not matter. All right. So remember, slope is rise over run. Rise over run. So you start here and you're going to rise. You're going to rise. So I'm going to use those little dots for right now. I'm going to rise. So I'm rising. Oops, sorry. So I'm rising. And you rise up until you get to the horizontal segment of this one. So it's kind of like, you see how I'm drawing a triangle. I'm drawing a right triangle. That's what I'm really doing. I'm drawing a right triangle. So I'm rising, and then I'm going to run. I'm going to run. Now make sure you start running when you're level to this point. Okay, so you see this right triangle I've drawn? This right triangle? Okay. So let's talk about rise. Now when you go up, when you rise, when you go up, that's going to be a positive value. And when you go to the right, that's going to be a positive value. So keep that in mind. Up is positive. Right is positive. Okay? All right. So when I go up, all you're going to do is just count the number of units. So 1. So I start here. So I go 1, 2, 3, 4, 5, 6, 7. So my rise is 7. And then my run, you count your run. You do the number of units. 1, 2, 3, 4, 5, 6, 7. Okay, so it's 7 again. I didn't mean it to be both the same. Make sure I didn't mean it to be both the same. Numbers, but it'll work. When I drew this line, it's all right. When I drew this line, I did not mean it to be the slope to be an integer. I wanted really to be a rational number, an improper fraction or a proper fraction, not an integer. Okay, but it's okay. So I go up 7 units, to the right 7 units. Okay, and so based on this, I can say that the slope is rise over run. And so my rise is 7, my run is 7, and then reduce if you can. I can reduce this, so my slope is 1. Okay, so the slope is 1. All right, now, so remember I started here and went here. Now let's suppose I start here. All right, let's talk about this. Suppose I start here. All right, and so I'm going to go to this other point now. So again, do rise first. Now rise basically mean up and down. All right, so rise is going to be up and down. Rise doesn't always necessarily mean you must go up. Okay, so when we talk about slope, rise over run, rise is going to mean either go up or you go down. Run is going to mean either you go to the right or you go to the left. Okay, all right, so I'm going to start here and I'm going to go down. So I'm going down. So I'm kind of doing this. I'm going to draw a right triangle again. I'm going to start going to the. I'm going to start doing my run when I get to this level, to this point right here, to this other point. So then I'm going to start doing my run here. Okay? All right. So now let's talk about this. So I started here. Remember, I started this point, and I'm going to this point now. So I'm going down this time. So when you go down, it's negative. When you go down, it's negative. So what that means is this. I'm going to count the number of units. So I'm counting 1, 2, 3, 4, 5, 6, 7. It should be the same as this one, right? Okay, but when I talk about the rise, I'm going to label it as a -7. When I talk about the rise, I'm going to label it as a -7. And the negative indicates that in terms of the context of what we did, I went down 7 units. That's what that means. And then my run, so I'm going to the left. So 1, 2, 3, 4, 5, 6, 7. Again, it should be the same number of units as above, but this time my run is -7 to indicate that I went to the left 7 units. But it did not matter, it did not matter, excuse me, it did not matter whether I used started here or started here. Again, it doesn't matter because a -7 divided by -7 is a +1. So I get the same slope. I get the same slope. Okay, so let's talk about finding the slope of this line. All right, so I want you to notice this, and it's going to be important. So you see this line right here rose. So I remember as I went from left to right, my y values are increasing. Those y values are getting bigger and bigger. The y values now, we're talking about the y values. So the y values are getting bigger. See how this y value is -2 and this y value is 5? Okay, so as I go from left to right, my y values are getting larger. So notice the slope was positive. Slope is positive, and that's going to be important. So if your line rises, see the line rose, So if the line rises, and we're talking from left to right now, we always go from left to right. If the line rises, the slope is positive. Okay, so the line rises, the slope is positive. So that's one takeaway. Another takeaway I need you to get from this. So one was being able to use the idea of rise over run, and the other was to now see that if the line rises, the slope is going to be positive. Okay? All right, let's look at this one here. So I got to pick 2 points in this line. I got to make sure that I pick 2 points where the grid lines intersect. So let's see. Let's choose, and again, I make this up. So let's choose this one here. So this point right here is 5, -2. All right, and then let's find another place where, and right here. So let's get this point here. And so this point here is -4, 5. All right, so -4, 5 is the coordinates of this point, and 5, -2 are the coordinates of that point. But notice that when we did these, when we did rise and run, I didn't use the fact that what these coordinates were. All right. Now we will in a little while, but for our purpose, I just use this point and I use this point without even knowing what those coordinates are. So using this right here, the coordinates, knowing the coordinates does not matter. You're just counting the number of units, those little grid lines. You're just counting those units. Okay. But in a little while, we will use those coordinates when we talk about the formula. So there's a formula you can use. Okay, so let's do this now. So let's start here. I'm going to start at the lower end, and I'm going to go rise and run. Always do rise first. All right, it doesn't matter. You can do run first, but sometimes you tend to put that number in the wrong place. So always do rise first. Remember, slope is rise or run, so just keep that in mind. Rise or run. So do rise first. Okay, so rise, remember, means going up or down. So if I start here, I've got to go up. I'm not going to go down. If I go down, I'm going in the wrong direction. So I'm going to go up. So I go up like this. You're kind of drawing a right triangle now. Remember that, drawing a right triangle, and you're going to start running when you get level to this point. So I'm going to start running now. Okay. All right, and then I'm going to count the units. So I started here. I'm going to go 1, 2, 3, 4, 5, 6, 7 again. All right. And since I went up, remember, when you go up, that's positive. Okay. Now I'm going to go to the left. Now remember, I'm going to the left, so if you go to the left, that's negative. All right, so keep that in mind. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a -9. So I went up 7 units, and I went to the left 9 units, but when I go to the left, that's a negative 9. So that means this. That means that the slope, which is rise over run, and my rise is positive 7, and my run is negative 9. So my slope is a negative 7/9. Slope is a negative 7/9. Okay? Now, if I had started with this point, let's talk about this point, and then gone here, I would have done this. So remember, I always do rise first. So rise mean up or down. So in this case, I'm going to have to go down. So I'm going to go down. I'm going to draw my right triangle. Draw your right triangle, and then draw it so that way when you do the run, it's horizontal to this other point. Okay? All right. So this time, I'm going to go 1, 2, 3, 4, 5, 6, 7. So it's the same number as this one, but since I went down, I'm going to have to denote it as a negative 7. And then here I'm going to go to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Same number as this one. But since I went to the right, I'm going to have to denote that as a positive 9. And the slope is going to be the same number, same value. So my rise is negative 7, and my run's positive 9. So notice the difference depending on which point you use. So here, the numerator is positive 7, the denominator is a negative 9. Here, the numerator is a negative 7, the denominator is a positive 9. But it does not matter because it's the same slope, it's the same value, negative 7/9. All right, now remember, to see the slope is negative here, the reason it's negative is because as you go from left to right, see these y values? Those y values are decreasing. See how this y value is a 5 and this y value is a negative 2? All right, so your y values are getting smaller. So what that means is that in terms of the slope, your slope is negative. So if the line falls, I'm going to say this is falling, so if the line falls, the slope is negative. Okay, slope is negative. Okay, all right, now we're going to start talking about the formula that you can use for this. Okay, so let's look at this idea. Okay, so this is the same line we looked at earlier. See this one here, where we found the slope to be 1. But what I want to do here to develop the idea of what the formula is, let's go back and look at this where we're going to use the idea of rise over run again. So remember, that's where we do the right triangle. So I'm going to draw this right triangle. Kind of like this. And all right, now this time the way we're going to develop the formula is we're going to look at it this way. All right, so you see this where the in the right triangle where my right angle is, this point here has coordinates for -2. So that point has coordinates for -2. Okay, now remember when we looked at this earlier, the rise, depending on which of these points I used, the rise, remember this is the rise was either a -7 or a +7, depending on whether I went from this point to that point or from this point to that point. Okay? So what I want you to notice here is this. Okay, so remember, we're talking about the rise. All right, so notice that the x coordinates are the same. All right, so the x coordinates are the same. That kind of makes sense because my x value here is 4. But the y coordinates are different. See, this is 5 and this is -2. Now, what I want you to think about is this. Remember, for going from here to here was 7, depending on whether I went from here to that point or from that point to that point. Okay? So what I want you to notice is this. So that's 7 units. Remember, 7 units. I can get 7 units. By doing this. See this y coordinate? That's 5. And I'm going to subtract the other y coordinate, which is -2. And when I subtract those, when I subtract those, I get 5 plus 2, which is 7. Okay? And when I do the, remember that's the rise. And when I do the run, so remember the run was also 7 units depending on where you started. So when I do the run, again, the run, so remember the run deal with the x-axis, so you can look at the x-coordinates this time. So look at the x-coordinates. I'm going to start with this x-coordinate, the one on the right. It doesn't matter. You can start with the one on the left. It does not matter. Okay, it does not matter. But in this case, I'm going to keep it consistent with what I did here. So I'm going to say 4 subtract, so this x-coordinate, subtract this x-coordinate, which is -3, and 4 subtract -3 is 4 plus 3, which is 7. And so my slope, which is rise over run, so this is 7, this is 7, so we say 7 over 7, which is 1. Okay? Now if I use this one, if I go to this idea, again, I'm going to draw my right triangle. I'm going to draw the right triangle. And so we're going to learn in a little while that you must be consistent with the order in which you start. So in other words, if I find my rise starting here, okay, and you can see what I'm talking about. So let's just go ahead and find this point. So this point here is 4, -2. No, I'm sorry, -4, -2. All right, so to find the rise, you're going to say 5. Remember, rise is it's parallel to the y-axis, so use the y-coordinate. So 5 subtract a -2. 5 subtract a -2, which is 5 plus 2, which is 7. And that's what we had gotten right here as a slope. Okay? I'm sorry, as the y value, 7 or -7, depending on which point I started with. Okay, so I'm going to start here. Okay, and so here, my run, I'm going to use this y coordinate. So I'm going to say, I'm sorry, the x coordinate. Remember, your run is the x-axis, parallel to the x-axis. So you use the x coordinate. So you can say 5 subtract a -4. 5 subtract a -4, which is 5 plus 4, which is 9. And that's what we had gotten here. Okay? But remember, though, you got to be careful when using this idea, because what some of you are going to say is that the slope will be 7 over 9. But it's not 7 over 9 because remember, this line falls. So it has to be negative. So you're just going to say this is going to be a negative. You know the slope is negative. Sorry. The slope is negative. So you say negative, and then you say 7 divided by 9. All right? So just remember that you got to be careful when using this approach here that I just did, because the slope is actually negative, because remember the line fell, so that's a negative slope. So be careful. Don't say 7 over 9. That would mean that's a positive slope. So just put a negative in front, like we did here. So the slope is negative. But that's not the way you're going to do this, though. We were just talking about this so we can at least develop what the formula is. All right, so here's the idea of the formula. Okay, so I'm going to go back right here, and I'm going to draw a grid line. I'm sorry, a coordinate plane. All right, so here's my x-axis, here's my y-axis. All right, I'm going to put 2 points in this plane. All right, I'm going to draw this line. So I'm drawing this line, just like this. And I don't know what the actual coordinates of these points are, so I'm just going to call this, I'm going to call this point right here my first point. This is my first point, just my second point. I'm going to call this point right here x1, y1. So the x1, that's the x1. So the x1 and y1. So the notation here indicates that whatever this x-coordinate is, that's the x-coordinate of my first point, and whatever this y-coordinate is, that's the y-coordinate of my first point. And then here, I'm going to call this one x2, y2 for my second point. So the subscript 2 is for the second point. So whatever this x value is, that's the x-coordinate of my second point, and this will be the y-coordinate of my second point. Okay, so I'm going to draw the right triangle just like I did before. I'm going to draw the right triangle just like I did before. I'm going to find this point here. Okay, and so when I find this point, so remember, you're looking at this point here, so you got to look at this x value in the x-axis, and you got to look at this y value. All right, so notice that this x-coordinate, remember when we did this one right here, we did this, wrong one. So when we did this right here, I think I lost it. Okay, here we go. So we did this. Remember, these x-coordinates were the same. So this was 4, this was 4. So the same idea here. So this is x2, then this right here has to be x2. So this is x2 right here. And then here, that will be y1. So that's y1. So this is x2, y1. So this point right here, so remember you're going to go to the right x2 and you're going to go up y1. Okay? All right, now what we just did a while ago was we subtracted the y coordinates. So this will be y2 minus y1. So that's your vertical change. Remember, this is your vertical change. Okay, now over here, my horizontal change, I'm going to say x2 subtract x1. x2 subtract x1. So that will be your horizontal change. Okay, so that'll be your horizontal change. That'll be your run. So therefore, the slope, so now we can talk about the formula. So the slope and the symbol for slope, the symbol for slope is the lowercase m. That's the symbol for slope. So the slope, remember it was rise over run, vertical change over horizontal change in y over change in x. So the slope will be y2 subtract y1. So basically, that means you subtract your y coordinates. Now, the order matters, so that's where this is going to be important. So remember a while ago when we discussed that, I keep losing this page. Remember a while ago when, here we go, when we were talking about this, the line that had negative slope. Remember how we said this was 7, but you have to be careful to make sure that you remember that the slope is actually negative because the line fell. That's where this idea is important. So in the numerator, you're going to subtract your y coordinates. So you're going to say y2 subtract y1, but since I started y2, I have to start with x2. So you start with x2. So x2 subtract x1. Okay? Now, it does not matter. You could have said y1 subtract y2, y1 subtract y2, but the order of the denominator matters now. So since I started with y1, I have to start with x1. Okay? But most students remember the formula as this one. So this is the one that you're normally going to see is y2 subtract y1 over x2 subtract x1. Okay? All right, so let's use those. So it's easy to use. All right, so now we know the formula for slope, and the symbol for slope is lowercase m, is y2 subtract y1 over x2 subtract x1, and the order matters. So this is y2, this is x2, this is y1, this is x1. Okay, now remember the y coordinates go in the numerator, the x coordinates go in the denominator. That's important as well. Okay, so let's look at some examples. Okay, so the direction is going to say this. All right, so here are the directions. The direction is going to say, find the slope. All right, so, all right, let me pause this for a moment. Okay, so basically we're going to find the slope of the line that passes through the given points. All right, so remember to find the slope of a line, you need 2 points on that line. All right, so let's look at this one. Suppose we had 7, -2, and the other point was, let's say, 5, -8. Okay? All right, so 7, -2, and 5, -8. Now, remember the slope formula. The slope formula is y2 subtract y1 over x2 subtract x1. All right, so the best thing to do is to use this formula. Now, remember, you could have plotted those 2 points, and then you could have used rise over run like we did before. But just use the formula. That's the idea now. Just want you to use the formula. Okay, it helps. It helps if you label these points. Now, by that, I mean this. If this is my first point, and it doesn't matter, you can set this to be your first point. It does not matter. You're going to say x1, y1. And then this becomes x2, y2. Okay? And then all you do is just plug into this formula. So the slope will be y2, which is -8, subtract. Now, let me just remind you why it's subtraction. So when we did this right here, we said subtract the y coordinates. It's subtraction because remember the word here is a change. So it's a change in y coordinates. So when you talk about change, you think about difference. So that's subtraction. Okay? So you talk about difference, so that's subtraction. So that's why we use the word change. All right, so y2 subtract. Remember, it's always subtract y1, and y1's a -2. So notice I put -2 in parentheses so I don't mess this up. Then the denominator, since I started with y2, since I started with this point here, I got to start with this point here. That's what that means. So since I start with -8, I have to start with 5. So 5 subtract, so x2 subtract x1, and x1 is 7. All right. Now, if you don't remember your sign rules very well, don't make a mistake. You have a calculator. Use your calculator. So when you use your calculator, whether you do it using the rules, 8 subtract a -2, -8 subtract -2 means -8 plus 2. And then this is 5 plus a -7. So all I did was just change the subtraction to an addition problem. So I add the opposite, And then -8 plus 2 is a -6, and then 5 plus a -7 is a -2. And a -6 divided by -2 is a +3. All right, so my slope is 3. Now again, what that means, remember what that means. So you answer the question, so that's the answer. So the slope is 3. But remember what that means. Remember, since the slope is positive, remember that if you were to graph this, the line rises. The line rises. Okay, let's look at number 2. So it's not that difficult. All you do is just label. It helps if you label these like I just did, and you put it into the formula. Okay, so number 2, suppose we had -4, -7, and 2, -10. I'm making this up. All right, so again, we want to find the slope of the line that contains these 2 points, that passes through these 2 points. So label these. It helps if you label. So let's call this x1, y1, x2, y2. Okay? All right, and so the slope, remember, is y2 subtract y1 over x2 subtract x1. So we're going to start with -10, y2, subtract y1, which is -7, divided by, now remember, since I started with y2, I have to start with x2, okay? Start with x2. So x2 will be 2, subtract x1, which is a -4. All right, so again, use your calculator. If you're not very efficient, or I should say proficient at sign numbers. So this becomes -2 plus the opposite, +7, -10 plus a +7, and this is 2 plus 4. Add the opposite, so as we get +4. And -10 plus 7 is a -3. 2 plus 4 is 6, and when I reduce this, I get -1/2. So the slope is -1/2. All right, and again, remember what that means is that in this case, if you were to plot those 2 points and draw your line would fall. So in this case, the line falls. All right, now what I want you to remember is this. So remember when we did the formula here? We did this formula. Normally, the formula is written as y2 subtract y1 over x2 subtract x1, but you could have started with y1 first. So you say y1 subtract y2, but if I start with y1, I have to start with x1. You must start with x1, otherwise you're going to get a wrong slope. So x1 subtract x2. So I want to go back here, and so we used, to get this one, we had used y2 subtract y1 over x2 subtract x1. So that's how we got that. But let's go ahead and use the other one. So let's suppose that you started with y1. Now it's very important that you remember your y coordinates go in the numerator. So y1 subtract y2. Now since I started y1, I've got to start with x1 subtract x2. All right, so let's see what happens. Well, okay, so y1 is -7. And I'm going to subtract y2, which is -10, divided by, now remember, since I started y1, I've got to start with x1, otherwise I'm going to get the wrong slope. So x1, so the x1 this time is a -4, subtract x2, which is 2. All right, so this becomes -7 plus 10, and this becomes -4 plus a -2. And so -7 plus 10 is 3, -4 plus a -2 is a -6, but notice when I reduce, I still get the same slope, okay? So it did not matter whether you used y2 subtract y1 over x2 subtract x1 or y1 subtract y2 over x1 subtract x2. It does not matter, your slope will be the same. But you got to use the order. If you start with y2, you have to start with x2. Start with y1, you have to start with x1. Okay? All right, now let's look at one more with this, and we're going to look at vertical and horizontal lines. Okay, so let's suppose we had this. Suppose we had, let's say, 4, -6, and -2, 10. All right, so 4, -6, and -2, 10. So again, let's find the slope of that line. So this will be x1, y1, x2, y2. All right, so you label it. It helps if you label. And so we use the slope formula, y2 subtract y1 over x2 subtract x1. And I'm just going to plug these values into the variables. Well, y2 is 10 minus y1, which is a -6, divided by, now remember, you're subtracting, so you guys say subtract. 10 subtract, okay, y2 subtract x2, which is -2, oops, -2, that's -2, subtract x1, which is 4. And so 10 subtract -6 means 10 plus 6. -2 subtract -4 means -2 plus a -4. 10 plus 6 is 16. -2 and a -4 is a -6. When I reduce, I get a -8/3. They're both divisible by 2. So that slope here is negative. And again, what that means, since slope is negative, what that means is that the line would fall. If you were to graph these 2 points, and let's just quickly just estimate where they are, just to show you. See, 4, -6, remember, is in the 4th quadrant. So 4, -6, let's say, is here. So 4, -6 is the 4th quadrant. 1, 2, 3, 4. -2, 10. So you go to the right, go to the left 2 units and up 10 units. So -2, 10 is in the 2nd quadrant. And when you graph the line, notice the line falls. So notice that the slope is negative. Okay? All right. Now, let's look at this idea. Okay, so this is number 4. Number 4, let's suppose you had this. Suppose you had 6, -2, and the other point, let's say, is -1, -2. Okay, so 6, -2, and -1, -2. Again, let's label these. So x1, y1, x2, y2. Okay? All right, now I'm going to find the slope. So the slope is, remember, y2 subtract y1 over x2 subtract x1, change in y over change in x. Remember, change means to subtract, so that's why we're subtracting. So y2 subtract y1, since I started y2, I got to start with x2. y2 is a negative 2, subtract y1, which is a negative 2. So notice that these y coordinates are the same. You see that? The y coordinates are the same. So in the other three, the x and y coordinates were different. Here, the y coordinates are the same. So let's see what that is. Let's see what that means. So what, negative 2 subtract negative 2, and then my x2 here is negative 1, subtract 6. So this numerator becomes negative 2 plus 2. Remember, add the opposite. So it's always change subtraction to addition. So when you change subtraction to addition, you add the opposite. So the opposite of negative 2 is a positive 2. Here, you're going to add, you're saying negative 1 subtract a positive 6. So it becomes negative 1 plus a negative 6. But the numerator, negative 2 plus 2 is 0. The denominator is a negative 7. And remember, 0 divided by negative 7, don't leave it like this. Okay, we expect you to know that 0 divided by negative 7 is 0. So the slope is 0 here. The slope is 0. So let's see what that means. If I were to graph these 2 points, I want you to notice something. So let's graph 6, negative 2. So 6, negative 2 is in the fourth quadrant. And then negative 1, negative 2. So negative 1, negative 2 is in the third quadrant. And when I graph the line, notice that this line is horizontal. So this is a horizontal line. Notice I'm using the word horizontal. That's a horizontal line. And notice that the slope of this horizontal line is 0. Now let's kind of understand why the slope is 0. Because remember, if you look at a horizontal line, what did you notice about all these y values? No matter which 2 points you picked, what did you notice about all of these y values? Well, the y values were all the same. Negative 2, negative 2, negative 2, negative 2, negative 2. And so when you subtract, since they're the same, and we subtract two numbers that have the same value, you're going to get 0. All right. Now the x values are different, but the y values are the same. So a horizontal line, no matter what horizontal line you're looking at, the slope is 0. So it has a slope. It has a slope. The slope is 0. So basically, I want you to remember this. All horizontal lines have slope, well, let's do the slope of 0. So all horizontal lines have a slope. Now that has a slope, the slope is 0. So if the slope is 0, that means it's a horizontal line. If the slope is positive, that means the line rises. If the slope is negative, remember we talked about that, if the slope is negative, that means the line falls. Okay? All right. But now we know this. We know that if the slope, if the line's horizontal, it has slope 0. So if the slope is 0, it means it's a horizontal line. Okay? All right, let's look at number 5. Number 5, suppose we had this. Suppose we had, now remember in this problem, the y values were the same. But what happens if the x values are the same? All right, so let's look at that. So let's suppose we had 7, negative 3, and 7, 5. All right, suppose we had that. 7, negative 3, and 7, 5. Now, before we go on, I want you to graph these 2 points to see what kind of line we get. So again, notice that the x coordinates are the same. So when I plot the point 7, negative 3, that's going to be in the fourth quadrant. And then when I plot the point 7, 5, that's going to be in the first quadrant. And when I graph the line, notice that this line is vertical. So that's a vertical line. Okay, that's a vertical line. And so let's look at the slope. So the slope, remember, is y2 subtract y1 over x2 subtract x1. So here's my x1, y1. Here's my x2, y2. All right, so I'm going to say 5 subtract a negative 3 divided by x2, which is 7, subtract x1, which is also 7. And the numerator is 5 plus 3, and 7 minus 7, or you could say 7 plus negative 7, but that's just 0. So I get 8 over 0. Now don't leave it like this. We expect you to say, now remember this, in a previous course and even in this course, whenever you cannot divide by 0. So if you were to put in your calculator 8 divided by 0, you get maybe domain error, or you get the word error or something like that. So you cannot divide by 0. So 8 divided by 0. So remember when you divide by 0, we say that's undefined. Okay, undefined. Okay, so the slope is undefined. So that's how you would say that. Right, slope is undefined. All right, now we tend to also say it has no slope. All right, but it gets a little confusing for students because they think when it has no slope, they think of the word 0, or they think of the number 0. So remember, this has a slope. This line has a slope. Its slope is 0. This line, so remember the horizontal line, a vertical line has no slope. So just say it's undefined. The slope is undefined. Slope equals undefined. Okay? It has no slope. So I want you to notice this. I want you to say all vertical lines have slope that's undefined. Okay? So if you have a vertical line, the slope is undefined. All right? Okay. All right. So now let's look at this idea. Okay, so the next part we're going to talk about is this. So if you're given an equation, see here we're given points and we found the slope. If you're given the equation of a line, you can find the slope without determining points. And so that's going to be the next part of the lesson. So we're going to end this lesson. So in this lesson, all I wanted you to be able to do was given a graph, find the slope using the idea of rise over run. Given 2 points, find the slope using the slope formula. That's all I want you to be able to do in this lesson. The next lesson is given an equation of a line, find the slope. So that's what we're going to talk about next. All right, so that's going to end this lesson.